The translated ellipse means that the center is no longer the origin. It could be hk, could be something else, and this is how the equation looks like. Notice it would be x minus h squared plus y minus k squared. Um, Now this is an example of a horizontal ellipse similarly because a squared, the bigger number, is under the x. Now instead of memorizing these formulas for the vertices and the minor x's and points, these are kind of nice if you're working on the homework and you're trying to get the exact points. What I usually do is I figure out what the center is, which is hk, plot that, and then once we figure out the a and the b, then it's basically the distance in either direction from the center. Like for example, A would be the distance right and left, for example, for horizontal ellipse from the center in either direction, and B would be up and down for horizontal ellipse. Again, we think of A and the B as the distance in this case, not so much the coordinates. And same thing for the foci. Now let's take a look at this example right here. Notice it's equal to 12, so it's not in the standard form. So to get it to be in the standard form, we have to divide by 12. And so we do that, and once we divide it by 12, notice how 3 divided by 12 is equal to 4 in denominator, 4 divided by 12 is equal to 3 in denominator, and that is actually equal to 12 divided by 12, which is 1. Now first we have to figure out the center. What do you think the center would be? If you think it would be the opposite of these coordinates, you are correct. It actually would be 1 comma negative 2. So let's take a look. So once we figure out the center, 1 comma negative 2, that was actually an example of horizontal ellipse because a squared was under the x. So again, a squared is 4, we find a, which is 2. B squared is 3, which is not a perfect square, which means b is square root of 3, which we can actually get as a decimal for graphing purposes. C squared is, we subtract a squared minus b squared, we get 1, which means c is also 1. Now, I conveniently followed the formula, but again, we didn't really need to. But because the major axis is on the x-axis, we only changed the h this time, and that's how come I subtracted the 2 and I added the 2 to the x only, and that's how come I got the vertices. Notice it. Only the x has changed because the major axis is right under the x. Now, minor axis, the y would change, so this is how we plug in. Negative 2 minus square root of 3 or negative 2 plus square root of 3. Now I calculated those on the calculator so we could graph, and those are the points I got. Now foci, again, because the foci are on the major axis, which happens to be on the x, only the x would change. So that's how come I got these points. So notice when we plot, I plotted the center first actually to try to graph it. Now notice the distance, the major axis was, if you recall, 2, because a squared was 4. So the distance 2, either to the right from the center or distance 2 to the left of the center. That's how come I got those points. Also notice up and down the distance is square root of 3, which we found those points approximately, and those I plotted. And here are the foci, which would be distance 1 in either direction from the center. And that's how I got the graph for the ellipse. And that's it.